Hello, friends. I am Satish Lele. I am a chemical engineer. I am working in field of piping for last 30 years. This video is part of my chemical process piping channel on YouTube. This video is about pressure drop in pipes. Pressure drop is decrease in pressure from one point in a pipe or tube to another point downstream. Pressure drop occurs due to frictional forces acting on a fluid as it flows through the tube. The frictional forces are caused by the resistance to flow. The main determinants of resistance to fluid flow are fluid velocity through the pipe and fluid viscosity. Any liquid or gas will always flow in the direction of least resistance or less pressure. Pressure drop increases proportional to the frictional shear forces within the piping network. Low velocity will result in lower or no pressure drop. High flow velocities and/or high fluid viscosities result in a larger pressure drop across a section of pipe or a valve or elbow. Low velocity will result in lower or no pressure drop. A piping network containing a high relative roughness rating as well as many pipe fittings and joints, tube convergence, divergence, turns, surface roughness, and other physical properties will affect the pressure drop. Pressure drop can be calculated using two values, the Reynolds number, 3, which determines laminar or turbulent flow, and the relative roughness of the piping. In formula for Reynolds number, d is the diameter of the pipe, v is the velocity of the fluid, is the density of the fluid, and is the dynamic viscosity of the fluid. The relative roughness of the piping is usually known by cross-referencing the Reynolds number with the relative roughness. The friction factor, F, is calculated. The velocity of hydraulic fluid through the pipe, tube or hose, is dependent on flow rate and cross-sectional areas. Recommended fluid velocities through pipes and hoses in hydraulic systems are as follows in next slide. Velocity of fluids in pipeline is as follows. Pump suction line, 2 to 4 feet per second or 0.6 to 1.2 meters per second. Pump return line, 4 to 13 feet per second or 1.5 to 4 meters per second. Pump discharge line, 7 to 8 feet per second or 2 to 5.5 meters per second. Use values at the lower end of the range or lower pressures or where operation is continuous. Refer to the flow and velocity nomograms for more information. Alternatively, fluid velocity can be calculated using the following formula. V equals Q multiplied by 21.22 divided by square of V with V equals velocity in meters per second. Q equals flow rate in liters per minute. D equals inside diameter of pipe or hose in millimeter. 21.22 is a factor to balance units. Calculation of Reynolds number. Before proceeding to the pressure drop calculations, the Reynolds number needs to be known where R equals Reynolds number, V equals velocity in meters per second, D equals inside diameter of pipe or hose in millimeters. M equals kinematic viscosity of fluid at operating temperature in centistokes. The formula used to calculate the friction factor is dependent on the magnitude of the Reynolds number. If the Reynolds number is less than 2300, flow is laminar and the following formula is used to calculate the friction factor. Where F equals friction factor, R equals Reynolds number less than 2300. If the Reynolds number is between 2300 and 4000, flow is transition and greater than 4000 flow is turbulent. For Reynolds numbers greater than 2300 and less than 100,000, the formula can be used to calculate the friction factor. Where F equals friction factor. 3 equals Reynolds number greater than 2300 and less than 100,000. Formula used to calculate the pressure drop is given here. Where delta P equals pressure drop in bar per atmospheres. V equals velocity in meter per second. F equals friction factor. L equals length of pipe or hose in meters. Rho equals density of the fluid in kilograms per cubic meter. And D equals inside diameter of pipe or hose in meters. When more accuracy is required, head loss in fittings can be determined using loss coefficients K-factors for each type of fittings. In this approach, K-factor is multiplied by the velocity head of the fluid flow. The formula island H equals K into square of V divided by 2 grams here. H equals head loss in meters. V equals velocity of flow in meter per second. Thanks for learning. If you like this video, please give a like to my channel and subscribe it.